Hello everyone and welcome. So in this video I'm gonna solve a very important approximate integration problem. So let's read the question. How large should we take simple n in order to guarantee that trapezoidal and midpoint rule approximation for this integral is accurate within this much? Okay, all right, so what's the meaning of this question? Let's try to understand that first. Now you have the integral of x cube. Now you want to approximate this. Okay, so the integral is going from 1 to 2, right? You're integrating from 1 to 2. Now if you're going to use an approximation method, doesn't matter, midpoint or trapezoid or Simpson or left endpoint or whatever method you use, you have to divide this big interval into several sub intervals, right? Now how many intervals you want? 2, 4, 5? Like, I mean, n is the number of subintervals, right? So you want to decide how many subintervals you want. But the question has a limitation. Question says that you want to divide this big interval into n subintervals so that the error the error is actually smaller than 0.001. That's the accuracy. You want this much accuracy. That means the error should be smaller than 0.0001. Okay, again I'm saying you want to know how many subintervals you want to ensure that if you use trapezoid or midpoint rule, you get an error less than this amount. Okay, because here's the thing, depending on the number of subintervals you have, your error is going to change. Like if you have less number of subintervals, like I mean if you divide the total length between 1 to 2 into 2 subintervals, your error is going to be large. Now if you have 4 subintervals, it's going to be smaller. Larger the n, smaller the error. Okay, but you want to know a specific n value that you can choose so that your error is this much small. Now this is where error bounds comes into play. Now let's take the trapezoidal rule case, okay, and then later we can do the midpoint rule case. All right, so the error bound for the trapezoidal formula says, well, actually the formula is this. Now what's the meaning of this formula? Can you remember? Well, what you have here will give you the worst error, okay, highest error when you use trapezoidal rule. Now here's the idea, here's the trick. If you want this much small error using trapezoidal rule, all you need to do is you need to make sure the worst error or the largest error is actually less than what you want. Think about this. I mean, if your largest error is 0.0001, then definitely the real error from your approximation is going to be less than largest error. That means definitely going to be less than 0.0001, right? So here's what I want. What do I want? I want my largest error, the worst error, that means what I wrote here, to be less than 0.0001. Okay, that's why I have 0.0001 on the right hand side of the inequality, because this is the largest error. Okay, all right, and this is the error I want. Now here's the thing, I want to find n, how many subintervals. Now if you solve this inequality, you will be able to get n. So let me show you. Do we know k? Well, we know f. To find k, we know f, right? Function is x cube. So to find k, you need the second derivative. So the first derivative is 3x square. Second derivative is 6x. Now you want to find the absolute value of 6x, second derivative, which is absolute value of 6x. Now this is an increasing function, 6x, right? And it's going from 1 to 2. So the largest 6x can get in the interval of 1 to 2 is, you get the largest of 6x when x is equal to 2, right? So the k value is going to be 12. So we already discussed this in this video series. So k is 12. K is 12. B is actually, so these are the A and B values. So A is 1, B is 2. So B is 2 minus A is 1 cube divided by 12 n square. Now you don't know n, you want to solve for n. Okay, this error bound inequality will help you to find n. Let's simplify this. 12 times 2 minus 1 is 1. 1 cube is 1 over 12 n square. This is nice. Nice numbers. 12 cancelled out. Okay. So 1 over n square should be less than 0.001. Let's switch 0.001 and n square because both of them are positive. So the inequality doesn't change. So n square can stay here, can go there, and 0.0001 can go there. Now let's take the square root. Okay. Now we know n is always going to be positive. Okay, because n is the number of subintervals. You cannot have negative number of subintervals, right? So you want to find the square root of 1 over 0.001. Okay, so let's do this. 1 over 0.0001 means 10,000, right? Okay, so square root of 10,000 is 100. So here's the idea. If n is larger than 100, so this is what it means. If n is larger than 100, your worst error is actually less than 0.0001. If your worst error is less than 0.0001, your actual error is always less than worst error, right? So your actual error is going to be less than 0.001 if n is greater than 100. So what is the least amount of n we want this to be working? Well, if n is 101, then it's just enough. Okay, so if we have 101 number of subintervals, okay, in the trapezoidal rule, you're guaranteed to have that your error is going to be less than 0.0001. Okay, now this is with trapezoidal rule. Now let's do this with midpoint rule. Okay. All right, so the only thing that's going to change with midpoint rule is the error bound formula, but the idea stays the same. So the error bound formula for midpoint rule is actually k b minus a cube. This is 24n square. Rather than 12, you have 24n square. All right, so the same idea. Okay, so the same idea. So the worst case error, k times b minus a cube over 24n square, you want your worst case error to be less than 0.0001. Now what is k? K is going to be the bound for the second derivative, which is same as the trapezoidal rule result. Okay, k is going to be 12 and b is actually 2, a is 1. Those things are not going to change. 24n square. All right. Now 2 minus 1 cube is 1, so it's 12 over 24 n square less than 0.0001. 12 and 24 cancel out, so you're going to get 1 over 2 n square less than 0.0001. So what I'm going to do is I'm going to take n square to the right, 0.0001 to the left. So we are going to get n square. When n square is greater than 1 over 2 times 0.001 is 0.0002. Okay, so we want to take the square root of, okay, we want to take the square root of 1 over 0.0002. So what is 1 over 0.002? It's going to be 5,000. Okay, so I'm not gonna do the calculation. If you like, you can use the calculator. You really don't need a calculator here. Now you want to find the square root of 5,000. Square root of 5,000 is going to be 70.71. Okay, so if n is larger than 70.71 in the midpoint, when you use midpoint rule, you're guaranteed to have an error less than 0.001. Now n has to be an integer because the number of subintervals cannot be a decimal. So what can we take? N can be 71. Okay, if you have 71 subintervals with the midpoint rule, your error is definitely going to be less than 0.001. So let's do one small discussion before we finish off this video. Okay, so here's what happened. If you use, so we use two methods. If you use trapezoidal rule, or then if you use trapezoidal rule, if you take 101 subintervals, your error is definitely less than 0.0001. If you use the midpoint rule, when you use just 71 subintervals, then your error is going to be 0.0001. Which method is better in this case? midpoint rule, right? Because it needs less number of subintervals to get the desired accuracy. So you can quickly get the accuracy. Now this is important if you are doing this in a computer. You can save time, you can save computer efficiency, like, right? Because you need less number of subintervals with midpoint rule rather than trapezoid the rule. Okay, so this is the special type of problem I wanted to solve in approximate integration method. Now let's do the same with Simpson rule. Okay, similar type of question, because there's something tiny important that we have to discuss with Simpson's rule. Let's do that in the next video.